Chapter 11 really focuses on the idea here of an abstract data type, which in C++ we call a structure. So for those of you who have any of the other programming languages under your belt, really what we're looking at here is either a class or an object. We are going to look to combine some of our cardinal data types, right? So and I apologize, this is page 614. Things like characters, booleans, integers, floats, doubles, strings into one, I'm going to call it big, but it's one big, one more generally encompassing data type. So why do we have the idea of a data structure? Because it's combined of several smaller elements. So really, if we look at an abstract data type, what we're looking at is something like a student, right? So if you think about you as a student, you are comprised of a bunch of other smaller data types that are necessary to create a student object, right? So you are a student ID number, you are a first name, you are a last name, you are an address. Really, we can't just say address. Really, it would be a street number, a street name, a city, a zip code, and a state, and other stuff too, right? So you've got a GPA, you've got a program that you're enrolled in, things of that nature. Now, there's not one data type that we can use to describe all of those things, right? And it's clunky. At best, it's clunky. Really, it's probably even not functional to use the idea of clustering arrays together. So pairing, I know it's not really two, but it's referred to as pairing an array. Pairing all of these arrays together. So we would have a student number array paired to a first name array paired to a last name array paired to you get the idea. And that's unworkable because we are going to need to have just a tremendous amount of these essentially paired arrays that really make it difficult for us to be able to enter in data into, for one student. It makes it difficult for us to enter in or change rather data for one student. So with a structure, we can say this is what a student is comprised of, and we can give that abstract type all of the necessary components it needs. So we can fill it with integers and strings and doubles and whatever we need. And if we need to create several students, we can, throw those into an array of student types. That works too. And so if you've had other languages, Java, for instance, you have seen a class where we have an object of a class that is stored in a separate file from our main that has all of the components necessary to be able to interact with it. And that is what we are going to do here. If you have seen object-oriented programming through things like, Python, through things like, you can pick a language and really go from there. The one thing to keep in mind here with C++ is always that we are dealing with, at its core, a language that is much older than many of our other languages. So some of its implementations here in Chapter 11, I'm going to call it, it's called retroactive interference. If you have seen another language that works a little less clunky, this is really going to be a trip, because those newer languages that maybe you have seen before are going to interfere with the way that C++ is implementing things. For those of you who have not had another structured programming language where you have dealt with classes or objects. The good news is when you do transition to another more modern programming language, so whether or not that's JavaScript or Java or pick something else, right? When you make that transition to another language, the transition is going to be made easier because you are going to have seen the notation, you are going to see some of that implementation that other languages borrowed and then later refined upon. So that is what we're going to see here in chapter 11. It's you as a developer being able to define your own data types, and that's what makes them abstract, because you can't point to a thing, a one thing, and say, a student is made entirely of a student ID number. That's incorrect. A student is comprised of a collection of other data types. And that's going to make, I think, a lot of sense for us moving forward, because that's how life works, right? Something is a collection of other attributes that makes it that way. We are here going to start letting code imitate life.